Hey everybody. So in this video, I want to introduce something that we're going to talk about in some detail in the next few videos. But I just kind of want to get the idea out there because it can be a complicated topic with lots of little tiny details that we have to move through. But the core idea, I think, is pretty understandable. So I just want to introduce it with a little idea. Okay. So here's what I want you to imagine. Suppose I make you the following offer. We're going to play a game. And here's how the game works. We're going to flip a coin. All right. And if the coin comes up heads, you pay me $1. And if the coin comes up tails, I'm going to pay you $2. Okay. Now, I tell you that I tell you that the coin is fair. In other words, if we were to flip this coin over and over and over again, the average number of times I would flip heads is 0.5. Half the time it would be heads. So that's what I'm telling you. This coin is a fair coin. Okay. However, you're a little suspicious, right? Looking at this game, if the coin was fair, I would end up paying you twice as much as you would pay me, and you'd walk away with a lot of money. So you might be suspicious, and you suspect that what's actually true is that I have a coin that flips heads more often, right? So this is the game. If you believe me that the coin is fair, you would want to play this game because then you're going to make money. But that would be a strange game for me to offer, and so you have a suspicion that I'm trying to trick you into playing this game. Okay. So here's the idea. You give me the benefit of the doubt and you say, okay, it's a fair coin. Can I test it? Can I take a few flips with it and see what happens? Right? And so you might decide to test it by flipping it 10 times. Okay? And I agree, you can flip it 10 times and see what you think. And so I remind you, though, that even though we expect half heads and half tails, we know that if we flip a coin 10 times, every once in a while we get 6 heads or 7 heads or 2 heads or 3 heads, right? It doesn't mean it's going to work out perfectly every time. So we can't expect that a fair coin is going to get half heads and half tails, right? So we have to decide how we're going to conduct this test, right? It's going to be very difficult to prove I have a coin that's not fair, okay? So what we're going to think about is something we might call a rare event, right? So if I flip this, or if you test this coin and flip it, and a lot of the time it comes up heads, that's something that could happen by random chance, but it's got a very small chance, right? It's rare, right? And so if something is so rare that it's more likely I'm cheating you, you might consider that good enough evidence to tell me, I don't believe you, I'm calling you a liar, okay? So we now have this question of what's too rare. For instance, if I flipped 6 heads, or if you did this test and flipped 6 heads out of 10, that's not a very suspicious number. That seems like the kind of thing that would happen all the time. The number 10 feels very suspicious. If you flip this coin and it only came up heads, that would seem very suspicious. And so we need to figure out where to draw the line on how rare is too rare. Where do we say if it's this rare, in other words, if its probability is this small, right? Rare events have smaller probabilities. We've got to draw a line somewhere for a small enough probability that we say one of two things happen. On the one case, this is really just a regular old coin and we had this very rare event happen. Or Leo's a liar, and this is actually a coin that's not a fair coin. It's not a 50-50 coin. And in the beginning, right, that's a pretty big claim to think that I would go through the trouble of coming up with a coin that flips heads more often and then lie to you about it just so I could make a few bucks. So that's not something that's likely. But if the other thing, if it is a fair coin and the number of heads I flip is so rare that this other unlikely thing now seems more likely. Right? So we have to figure out where to draw this line. So this is a little bit of an arbitrary line to draw, right? And we're not going to spend a lot of time in these videos to deciding where the line should be. There are some general ideas about where we can draw them, some typical values we use, but ultimately they come down to some decision making, and it's a complicated idea that we're not going to go that far with right now. So for purposes of this this little experiment, this little thought experiment, let's say we will say too rare is something that happens less than 1 out of 50 times, right? In other words, the probability of the event, whatever this event is less than 0.02. That's 1 out of 50, okay? So we're drawing a line and saying, here's my line. If something is 2% or more likely to happen by random chance, I'll have to accept it as this is a fair coin. I just happen to flip a bunch of heads. If it's less than 1 out of 50, less than 2% probability of happening, I'm going to say, you know what? I'm more confident that the mean you told me is wrong than I am that we had this rare event, and I'm calling you a liar. Okay? So, well, let's think about our event now. We have, if I in this test, I'm going to be testing the number of heads flipped, the number of heads flipped out of 10 tries. And it turns out this thing follows a binomial with 10 trials and a probability of success of 0.5, right? Because I'm assuming you're correct, and I'm saying if it was true that the probability of having heads is 50%, how rare is the event of flipping a bunch of heads, right? And we're looking for how many heads we have to flip to have less than 0.02 probability. In other words, I'm looking for probability that X is greater than or equal to what number gives me a probability less than, less than 0.02. Okay? And so since this is a binomial, this is pretty easy to compute. It turns out that the probability of being greater than or equal to 8 is 0.0547. That's too big. But if we look at the probability, oops, forgot my X there, of X being greater than or equal to 9, that only has a chance of 0.011. Right? So here we found that if we flip 9 or 10 heads in this test, or you flip 9 or 10 heads in this test, you've crossed the rare event line. In other words, there are two possibilities. It's a fair coin and a rare event happened, or Leo's a liar and the coin is rigged, meaning it has a greater than 50% chance of flipping heads. And so because of our decision of where this line is, between which one we decide, we would say we are going to assume this is true if X equals 9 or X equals 10. Otherwise, we'll assume this is true, right? And then you perform your test. You now have a line you've drawn, and if it gets to be 9 or 10, then you say, I don't believe what you said. I think your suspicions are correct. On the other hand, if I flip 8 or less, you say, okay, you know what? I don't actually have enough evidence to be comfortable calling you a liar, right? But notice, this is an arbitrary number. If we picked a different number, we may have only needed to flip it 8 times, right? So we made that choice before we started flipping. We decide ahead of time what's crazy enough that will, right? This is flipping 9 heads is very crazy if we have a fair coin. It's less crazy to think I'm a liar, so we'll take this as the truth in that case. We've proved nothing, right? But we've gathered evidence. And so that's at the heart of what we're going to call hypothesis tests, right? We're going to learn 3 different kinds of hypothesis tests in the next videos. They're going to have different details to them, very similar to confidence intervals. We don't actually use the binomial. We're going to relate things back to the normal distribution. I just wanted to do kind of a simple example that has the same characteristics as these hypothesis tests. So we will get into the details of those in the next few videos. Thanks, everybody. I will see you next time.